Hello everyone. In this video, I am going to do a simulation for IR sensor using an Arduino Uno board. IR sensor is an infrared sensor, that is an electronic device that emits and detects infrared radiation. It commonly used in various applications such as object detection, proximity sensing, and remote controls. An IR sensor typically consists of an IR LED that emits infrared light. Then the output signal is detected using IR light. If it exceeds a certain threshold, then the sensor outputs setting it to the high signal, or else it output will setting to the low signal. If a high signal means the infrared radiation is getting detected. Now we will go into the coding part and we can break the coding part line by line. Now this is the coding I have written for IR sensor. So int IR pin equal to 13. I am initializing a global variable here. This variable declaration is named IR pin and initializing the value to 13. That is the IR sensor. We are connecting the output pin to 13th pin of the Arduino Uno board. Now a void setup function is using. A void setup function is called once when the program starts. It is used to initialize settings. Like settings, what we are going to initialize into the program. We want to set it here over here. Pin mode keyword is used to set the pin which we are going to use. IR pin we are going to set it as an input pin. This sets the mode of IR pin. That is the 13th pin as an input. This means the Arduino will read values from the pin, expecting the IR sensor to provide either a high or low signal. That is expecting the IR sensor to provide any signal, high or low. High means the IR sensor is getting detected. Low means there is no reduction of the signal. Then there is a loop function. Loop function will continuously run till we stopping the simulation. Serial begin, we are using a serial begin 9600. This means we are initializing a serial communication. We are initializing this initializes a serial communication at a baud rate of 9600 bits per second. 9600 bits per second. This is the amount of baud rate we are going to initialize the serial communication between the board and the sensor. So we are using this 9600 bits per second. It allows the Arduino to send data to a serial monitor on your computer. That is our computer we are using. So this is the baud rate we are using, and for debugging purpose also this serial communication is used. So this loop, next we are coming into the void loop function. Void loop function runs repeatedly after the setup function has finished. Now here int IR value equal to digital read IR pin. This line indicates that reading the IR value, the line reads the current state of the IR sensor connected to the IR pin using the digital read function. So the value high or low is stored in the integer value, that is int IR value. If a high means like it will store 1, low means it will store 0 in the variable name IR value. So next we are reading the value from serial using serial.print. Printing the text. This prints the text value IR value equal to this, like it will print it into the visual terminal, and we are getting this value to IR value, and we are printing this value here using serial.println. The IR value is 0 means it will print 0, the IR value is 1 means it will print 1 after a delay of 500 milliseconds. This pauses the execution of the program for 500 milliseconds before the loop restarts. The loop is continuously starting now. So after continuously start, because it is continuously starting, after 500 milliseconds the loop will again start. After 500 milliseconds again it will go. It is going like that. So now we are going to do simulation. So we are compiling this program. Compile and extract the hexadecimal file .x file and dump it into the Arduino Uno board. To simulate the IR sensor in Proteus, we want to follow these steps. We will use some components like microcontroller, power supply, IR LED, and some other components, and we will do a circuit and adjusting parameters. Also, we want to IR sensor or versatile device that is widely used here in Proteus. So now we can compilation is done. Now we can extract the hexadecimal file over here. Yeah, now we can find a hexadecimal file here, and we copy the hexadecimal file, and this is the simulation I have done for this infrared sensor. So I am using an infrared sensor that is connected to the output of the 13th pin board, and I am using a visual terminal that is connecting the receiver and transmitter simultaneously. So ground is connected to the ground and VCC is connected to the power supply, and I am using a logic state which is connected to the test pin. This logic state is going to determine the value which is going to which is going to print in the visual terminal. IR value, if it is 0 means here it is 0 means the IR value will be 0. Here it is 1 means the IR value will be 1. This test pin will initialize the value to IR sensor. That output will connected to the 13th pin. 13th pin is an input pin. That pin will determine the output from the IR sensor. So now I am going to run the program. Now a visual terminal is coming. The IR value is 0. The IR value is now it is 0 here in the logic state. So it is 0 in the visual terminal. After 500 milliseconds, the loop will again run, and the IR value will be same. So now I am changing the IR value. Now I am changing the IR value as 1. So after 500 milliseconds, the IR value will be displaying in the visual terminal as 1. So wait for the 500 milliseconds for the delay we have providing. Yeah, IR value is equal to 1 now. Again after 500 milliseconds, the IR value is same 1 now. After I am changing the IR value, now the logic state as 0 means the IR value will be also changing as 0. Now I am going to change the logic state value. Now I am changing the logic state value as 0. Now after 500 milliseconds, the IR value will be 1. 0, sorry, 0. Okay, thank you. This is the simulation for IR sensor.